Hello, hello. Nice. Hey, Brent. Hi, unexpected maker. Thanks for showing up. I got the chat working. Hi, Eric. Right on time. Looks like everything's going. I know, like, Restream was warning that Twitch was having some problems. But that's all right. Ah, thanks, Brent. Yeah, I was fussing around with Restream. Because I think somebody asked about it yesterday, or last week, so I thought I'd try. Hey, Simon. Thanks for dropping by, and Juan. I'm just going to wait a little bit longer. Maybe I'll stand. Don't need to sit. Hopefully we won't crash 3 times like last time. Although I did update OBS. That was me. Easier to see combined chat on the screen. Yeah, for sure. I have 2 copies of it up here, though. Hi, Gordy. From Toronto. All right. 1 more minute, and then I'll get going. Unexpected. How was your week, Scott? It was good. I did a lot of reviews and stuff. It did not. I'm using OBS with Restream, so the chat is from Restream. Hey, Fred and Dining Phil. My week was, I got stuff done. I'm trying to get the lower power stuff like wrapped up, but we basically had like 3 pretty big PRs come into CircuitPython. One was the stuff that Jeff Epler's doing, which is the Rgb Matrix thing. So I had the I have a big RGB. Actually, I can show you what Rgb Matrix. So it's basically a bunch of neopixels in a grid, and Jeff is getting it so that you could do like REPL on those, which is cool. And I'm gonna let the cat out too, because she, terrorizes things once I start talking. Hi. You want to say hi to everyone? What do you say? No? You like being held? Well, I'm gonna kick you out anyway. She doesn't like me disturbing her sleep when I start talking. Hi, Jim, from Redmond. You're close to me. I'm in Ballard in Seattle. Dining Phil says, love to see a tutorial on CircuitPython and the Circuit Playground to build a coronavirus color display. Yeah, there's some great tutorials on learn.adafruit.com. But today we're going to go a little bit deeper into the weeds. Anything Kid 123 says, once coronavirus disease 2019, COVID-19 loosens up, you can work on ESP32-S2 Feather or Metro. Yeah, so I do mostly software. Lady Ada, I think we'll do some Desk of Lady Ada's soon for those. She just put an order in for modules, so that'll be cool. Mike Kelly says, hello from my basement. The only things I've seen for weeks. Jim Bob Bennett says, hey, Brent. You're keeping me busy today fixing up that PR. Awesome. All right, let's get going. Let me just show you the splash screen because I like it. I'm a freelancer for Adafruit, so I actually do have my own company as well. And the thing in the middle is the logo, which is a chickadee. And I designed the logo myself, and I put it on all the circuit board designs that I do. So That's that. So, hello everyone. Thanks for joining on this Friday stream. I'm starting to do it kind of pretty typically. My name is Scott. I go by Tan Newt online. It was randomly generated in the late 90s. And sorry if there's any background noise, but last time I got really hot when I was streaming, so I opened the windows already. That'll be kind of a summer thing anyway. Um, I'm a freelance software engineer, but I basically contract full time for Adafruit, and I'm the lead on CircuitPython, which is easy to use, beginner friendly, beginner oriented version of Python for microcontrollers. So, taking small boards like this one, for example, making it plug in, show up as a drive, and you can just edit the code to Py on there. Um, while CircuitPython is for beginners, these streams that I do tend to not be. I call them deep dives because they are kind of in the deep, underneath CircuitPython sort of stuff. So last week I did a kind of like, here, let's just get tiny USB on the ESP32-S2 going. Let me eject it or not. So I had this. This is one of the dev boards from Espressif. I don't know if I can get it to be a bit sharper. But I just have the native USB plugged into just a dongle there to USB-A that I got off the Adafruit site. We crashed a couple times when we were installing the Scilabs drivers. Hopefully today we won't. What today is going to be hopefully is I've actually been waiting a little bit to work on this some more because I thought that this period that I want to do today is actually really important for folks to see creating a new port. So I don't know how far I'm going to get, but basically I'm going to start from the beginning of creating a new port for CircuitPython. Now, a port is kind of a collection or a broad category of a chip family. So a chip family is usually like characterized by the CPU core it has, the libraries that the vendor provides, and then like the way that all of the peripherals on the chip work together. So we have Atmel SAMD 21 and 51. They're pretty related, so that they end up in one spot. We have Nordic NRF 52840, which is from a different manufacturer, and then we also have STM, which we have both F4 and F7 and H7 support as of this morning, which is exciting. And so those are a number of them. We have one that's called LightX, which is actually for FPGAs. And that's the smallest and simplest of the ports because it's very limited right now. And so what I'm going to start with today is just establishing the new directory and trying to piece all the files together. And I think it will feel a little wandery because I'll basically, my plan is to take the LightX folder and basically trawl through it and change things in the way that I think that they should end up being. And we can kind of talk about the different things there. What we left off with last week was talking about some of the challenges of bringing CircuitPython to ESP32-S2. One was the memory hierarchy, so having external RAM, external flash. Another thing was this is the first time we're definitely going to build CircuitPython into a real-time operating system because the ESP-IDF, which is the vendor-provided library system that does all the networking and stuff. So we definitely want to use that. It relies on FreeRTOS, so like we have to use that. And that's fine. It's something we've been thinking about doing is starting to build on top of an RTOS. Afternoon, Summersoft. Thanks for joining us. And the last thing was the build system. So we in CircuitPython tend to use kind of complicated make files to basically say, here's all the different source files. They all get compiled using all these flags and stuff, generate the object files, and then here's how we link it all together. We use make to do that, whereas the ESP IDF doesn't use make. They use they have their own Python script called the idf.py. It calls out to CMake, and then in CMake is a meta build system, which means that it generates lower level files, either make files or Ninja files. Ninja is a more modern kind of take on make, but it's actually simpler. So like there's some crazy or weird stuff that make can do with logic and stuff, and Ninja can't do that. It's meant it Ninja is designed to be generated by a meta build system. So it's actually quite interesting, and I spent some time, I think it was last weekend, like prototyping what it would mean for CircuitPython to actually be built just by generating Ninja files itself, or like writing our own Python files to generate Ninja files. So I'm gonna try not to go that far. But I think today, if we get into the build system stuff, we'll hit some Ninja. Are there any questions before we get going? Before I start showing files and things? I think everything is rolling. It looks like YouTube's on, Twitch is on, LinkedIn is on, Mixer is on, Periscope's on. Thanks to Restream.io. I got the nice chat on this side over here, so that you'll be able to follow along to the folks that I'm replying to, and that will be on the other screen as well. I put it there too. All right. Well, I don't see. TwitchBot just put it in Discord that we are live on Twitch. I did try to hook up the Restream.io chat to Discord, but it was having trouble. So that's the one chat that if people do chime in on the live broadcast chat channel, that won't show up on the side panel. All right, I'm gonna switch back to my chair. I do have a standing desk, so you don't have to hear it go up and down. And let's switch. I think this will be kind of like another chance of like, it's really quite simple stuff that you start with. Okay. We're doing, so I don't have the overhead set up today because it's like another video source and I wanted to try to treat my laptop a bit nicer. So here's the browser stuff that I thought would be interesting. We can use it if we need to. First and foremost, what I want to do is I want to Control-C this. I was doing some exploration on the build stuff before I started. But where I wanted to start is actually some place that I think people don't necessarily understand with Git. So Git is a distributed version control system, and we use it all the time in CircuitPython, and I think folks don't necessarily know how to start something new in Git. So I wanted to actually show that. So what we have here is I always type git status. So if you're using Git, my first tip is run git status. If you don't know kind of where you're at, where you're going, run git status. It's super helpful. I've baked this into my brain so much that when I'm in GDB, I'll type git status and it'll be like, I don't know what that is. Not nearly as helpful in GDB. Okay, so what I want to do is I was actually just working on earlier updating TinyUSB, which is actually something that we'll want for the ESP stuff, but it was something that I also want to get committed separately before the ESP stuff is ready. So what I'm going to do is I'm going to commit this, push it, and then create a new branch. So let's not do that. I'm actually going to just remove this one directory that I don't actually need. I don't know why the git ignore is not correct, but I'm going to do that. And then I'm going to do git status again. And I should say, for those of you who haven't seen my streams, they do tend to be about 2 hours. So this is not kind of a compact structured thing like a lot of other Adafruit stuff is. This is going to be a bit more raw, I guess is the right word for it. Okay. Unexpected Maker says, slightly off topic, answer later if you want, but what is the shell decorator that you're using? Yeah, so it's, I use fish shell, which is the thing that's doing these autocompletes. Like if you see I typed git add and then the, and then the dot afterwards is an autocomplete. Fish is doing that for me, and then there's an extension called Oh My Fish, I think. Oh My Fish. The fish shell framework. And I think they have a list of themes. Maybe not. There is certainly themes. But the term I think for a font like this with the bar is Powerline. I think it's been a little while since I did this. But I've been really happy with fish. Most stuff just works. Of course, I searched for fish. What did I expect? A command line shell for the 90s. So auto suggestions, sane scripting. Pretty easy to install, actively developed. So yeah, it's mostly just stockfish with Oh My Fish, I believe, as well, for the theme. Okay. It's a completely different shell. It's not Bash or Z shell. If there's scripts that I need to run in Bash, I'll actually write Bash and then the script name. And I don't have to read the question off because it's on the screen. Perfect. Okay. So we're going to add that stuff. We're going to check our Git status again, and we're going to say update tinyUSB and add interrupt hooks. So there was a change that tacked it to tinyUSB that not allows, but requires the user of tinyUSB to create a function for the interrupt and then call the interrupt handler in tinyUSB. I wanted that because I wanted CircuitPython later, not now, but later, to be able to know when a USB interrupt happens and make sure that it runs the task call for tinyUSB afterwards. I was having some issues with that where the other thing I was working on was low power, and if you get a USB interrupt, tinyUSB queues up some work to do when it has the main task, and then if I go to sleep, then the USB gets all really unhappy. So I wanted to be able to make sure that, like, if something on USB happened, we could call the tinyUSB task before we swapped away. Okay, so normally what I would do to create a new branch is that I would I guess we're going to talk about Git here first. So one thing I really recommend with Git is to name your remotes based on the username of the person on GitHub. So you'll see, like, it typically has notions of, like, upstream and origin. And I've heard the argument that that's good because of it means that the names are standard across different repositories. But I actually have I end up in this mode where I have a lot of different remotes. And so I found it easier to actually just name the remote the actual username so I know what I'm referring to. So if I want to get the absolute latest of CircuitPython, I do git fetch Adafruit because that's kind of the canonical place. And then I could do git checkout Adafruit master if I were starting a new branch. But because I want the new version of tinyUSB, I'm actually going to just base it off that. So let's check out the update tinyUSB again. Going back to the branch that we were on. And I highly recommend setting up your shell so you can see what branch you're on, or if you're not on a branch. So for example, here, this is the git commit hash of the commit that we're on, but we're not on a branch. And then when we go back to a branch, it's green now because there's nothing different. So if we do git status, it doesn't show us anything. The moment we edit a file, it'll be either orange or red. Okay, but we don't want to work on this branch. We actually want to create a new branch. And so I think switch is the new hotness for this. So I'm going to do ESP32-S2 as my new branch name. This branch name is only local right now, but once I push it. And then the other thing I want to say is that when you create a new branch, branches are references to commits. And so if we look at our Git log right now, you'll see that head is the notion of what you have checked out. It's checked out to the ESP32-S2 branch. And this also shows that it's equivalent to the other branch that we were just on. So it's only later that when we start making commits for ESP32 that we'll go further kind of in that tree of stuff. And then we can also see that we're only one branch ahead of Adafruit master. And again, this would say origin if you use the standard Git convention. So I do recommend for clarity that you use the actual name or whatever. Yeah, Mark says it looks like Powerline for Z Shell. Yeah, it's very similar. It's Powerline for fish instead. But I think Z Shell's now the default on Mac. I don't know. I like fish. I like the autocomplete. Okay, the autocomplete tries to be smart based on the directory, which is kind of interesting. It doesn't always work, but I've had reasonable success with it. All right. No worries, Mark. All right, let's see what ports we've got so far. We're going to make a new one today, which I don't think I've streamed before. Maybe I have. It's been years. But it's not something that we happen to do a lot, and it's not something that we've documented that well. So I thought I would wait to stream it. My plan is that once I stream this, I'll be able to work next week on it without streaming it. I'll get more done. But I think I am going to try to do this Friday's time slot every week. Because no other Adafruit folks stream Friday afternoons, so it's kind of a nice spot to slip into. So maybe these will be updates and then one task or something. But I'm definitely I haven't worked since last week on ESP, but I do plan on working on ESP separate. Yeah. Mark is saying Z Shell is awesome. Much better autocomplete. Yeah, same is true for fish. Like Bash is old and not as good. Okay. So we've got 1, 2, 3, 4, 5, 6, 7 different ports. The Unix port we basically only use for testing. And the first thing I'm going to do is I'm just going to copy the Linux port into the ESP32-S2 directory. That's going to complain. So we'll do it recursive. That's not true. You've been updating. All right, now we've got another directory. And if we look at our git status, we'll see that we now have an untracked directory. Cool. So what I'm going to basically do now is I'll answer questions as they come up, but I'm basically going to look through that directory and start kind of poking and changing things. So I also want to, this is a conversation I copied out of Discord that I had with Ivan, who's been a huge help on TinyUSB, and he was willing to chat about some questions I had with the ESP IDF. He works for Espressif, so he's a great reference. So I'm actually going to save this in that new directory, which is why it's unsaved. And you can only see half my save dialog, which is fine. Ports, ESP32-S2, chat with Ivan. May not commit it, but I want to save it there anyway. And let's actually just close other tabs, because I was working on the other ports for the tiny USB stuff, and I don't want to don't want to keep working on that right now. I'll just break the other ports. It's fine. This is not going to be anywhere near ready to check in. Okay, so let's take a look. We got a board.h. Can start by updating the copyright. And yeah, this is going to be maybe boring. But we're going to want this. So I will copy and paste it. You're going to have a newer and better shell history. All right, there's our first file. Let's delete this. We don't need that. This is FOMO stuff. I was telling somebody about the stream. I was like, I think the stream's going to be mostly me deleting files. So we'll see. Let's rename this Saula. Is that what it's called? It's got a version, but yeah, we'll just call it Saula. This is all going to change, so don't fret too much. Yeah. Okay, so I didn't see Mark's question. So Mark asks, what's actually happening here? No idea the progress in CircuitPython on the S2. Yeah, so this is the start of it. Last week we were testing the tiny USB port for the ESP32-S2, which worked great once I got the drivers installed and the stream backup. And CircuitPython is pretty tightly coupled to tiny USB, so that's a huge thing to build on. Yeah, so this is the start of it. And let's just go through here. Make it as big as I can. All right, let's update the copyright. Display IO. Assert stuff is running okay. Let's just always run USB background and file system background. So basically my approach is to change a bunch of stuff and then chase fixes. Now the build system is going to be trickier, so maybe I'll do that at the end. Don't need this. The goal in the next week, I would say, is to get the CircuitPython running on the Saula, so that when you plug it in, it shows up as a drive, and there is and the serial terminal works. Like if we could get those two things, like that's the hardest part. That's the step that means that other people can help, like get digital I/O working and get bus I/O working and all that stuff. This is okay. This is specific to Lidex, so we'll delete that. I'm a little bit scared of the makefile, so let's just skip that briefly. So, hey Esden, thanks for joining. I'm gonna delete this stuff. And we don't want the NRLR thumb because we're not thumb. We're extensa. Default stack size, common root pointers. And I think that we'll just, oops, copied the wrong thing. I think the biggest hurdle will be the build stuff, and then the build stuff will bring us to the free RTOS stuff as well. So there's also so we have a couple configuration files. mpconfig port is the classic one. This happens just in pound defines. And then there's also mpconfig port.mk, which happens in the makefile side. So they also end up as defines, but it can influence which source files we actually use. Yeah, Mark says he's gonna order a Sala, so that they can test some of this. Yeah, the other thing about ports is that once we have one board going, it's usually pretty easy to add other boards. So as like unexpected makers boards come online, which should be pretty easy to add support for those. It's basically just naming, like, primarily boards are just how much flash, what flash you have, and then also like what do you name all the pins on your board. So it's pretty easy once we get one going. Okay, so we want to turn all this stuff off. Serial number, we don't know yet. We'll just leave it at 30. We do want USB support, so this looks fine to start with. These three imports are specific to the LIDX stuff, so we're going to delete that. And delay milliseconds, I'm going to just delete. And this ISR stuff, I'm going to delete. And I'm going to delete this as well, or delete the innards of that. Okay. And how port, blah, blah, blah. Definitely don't need this NRFX stuff. And I think there's a better format for these guards, but just go with that for now. This file gets deleted by my other stuff, so it's not that interesting. All right, let's look at the make file. We're 30 minutes in, and I couldn't procrastinate any longer. So I've got a couple references on where to take this. Let's just skim this conversation that I had. Ivan says, I was watching your stream and I had a couple of pointers. If you start using CMake and CircuitPython, it will be possible to import all of the IDF stuff as a CMake library, as in this example, the CMake lists.txt, which I think I have here. Yeah. So this is an example of a CMake file that says I want to use the IDF as a library, and it's C code. Yeah. This is a very nice CMake file. I've been a little bit wary looking at some of the other stuff, or some of the other CMake files that I found, which has kind of made me think I'd much rather just write all my logic in Python and then run Ninja. Or use Ninja to do the actual build, which is what CMake does as well. So I don't know CMake that well as well, which doesn't help. So that's one example. Until then, there's an alternative. Create a Hello World project with the IDF and then build it with the IDF build system. Then add a CMake target to dump the C flags and the LD flags of the main component into some file. Then you can read this file and use the C flags and LD files with make. I think this might be more the approach I'm going to go. It's going to be tricky. I guess one thing we could do is I do want to pull in the ESP IDF into here. And I was debating whether I should pull it into lib or I should pull it into the ports directory. I think I will actually do it into the ports directory because that matches where it is in other stuff. So I'm going to do git submodule add, then I'm going to find it. just over here. Yeah, I'm excited for S2 feathers. It's gonna be good. Just call it ESP-IDF. I definitely don't know what I'm doing. Look. All right, let's keep reading. So I also in my tab here, I have the example that we were building last time, so we can crib information from here as well. The idea is that you write a makefile which calls CMake to build the simple IDF project. This produces all the static libraries of IDF components, and then an extra rule in the CMake list saves the compiler and link arguments to some file which your makefile can read. Yeah, unexpected maker. My plan is to do it as a submodule inside the S2 port. Sublime probably has an integrated terminal, but I tend not to use integrated stuff. I'm really stubborn about it. I'm stubborn about it. The reason I'm stubborn about it is because I like to have a workflow that I can apply across languages and systems, which is also my justification for largely being a printf debugger. I only really use GDB when I can't get away with printf debugging, which can happen in like hard fault cases and stuff in CircuitPython. But yeah, probably. I'm not a Sublime power user. I use it mainly for the syntax highlighting. I did get fed up with VS Code though. I tried VS Code, and VS Code has great merging when you're doing Git merges, but it drove me nuts how often it would pop up things in the bottom right hand corner. Just drove me nuts. I was like, I don't need this. I don't need this. I don't need this. Okay. So the idea is to write a makefile that calls CMake to build this simple IDF project. So I guess if we want to do that, we should probably actually have the CMake file in the ports directory, which I think does make sense. One thing, like Unexpected Maker and I were talking a little bit, and I think the idea, I would like it to be, I would like the submodule, I would like the ESP IDF to be a submodule for the, I'm getting distracted by VS Code talk. I would like the IDF to be a submodule of CircuitPython. I would still like to be able to, for folks to be able to run the menu config stuff. But I would also like it so that we don't need to run install.sh or fish or whatever and that stuff. Like it, I guess that pulls down the tool chain, so maybe install.sh needs to be run, but the export stuff, maybe if we can get away with like hard coding relative paths, that would be my preference. I don't know. This is all like, who knows? I don't quite know where I'm going, but you know, this is kind of my theme of like honest development. Like, I consider myself a strong coder, and yet, you know, it's always a lot of learning. So the other thing I was pointing at, or Unexpected Maker had pointed me to the Laboris port, and I looked at this, and they have MicroPython as a submodule themselves, and I don't want to do that because as much as possible, I want to make sure that as CircuitPython evolves, like we can keep moving forwards. I don't want to pin versions of CircuitPython into some other repository. I want it all to be centralized. All right. Dormant for a while. Submodule is not a bad option. Keep in mind that if you want your users to be able to rebuild CircuitPython with slightly IDF commit, they'll need to manually change the submodule commit, and we already do that. Some Docker discussion. Blah, blah, blah. I'm still procrastinating. All right, let's look at the makefile and just see what we can change and run make and see what happens. We do have the IDF imported. So this we should really share it. We don't really need this, but I think this PyMake needs it, and we'll just leave it. Cross compile, we can update this. This is certainly not right. Let's do that. So I think the way that I'm going to figure out what it is, I know it's, yeah, I would like, so yeah, I would like to preserve the ability to run menu config and have it just automatically piped in. But I do want everything centralized. So hopefully I'm able to do those two things. Okay. This is not right. And in here, I have Ninja. So you can actually just look at the files that the IDF CMake generated. I say CMake and then I type CMake. I think it's got extensa in it. That's not what I want. These are just directories. I think it also might be. Oh, there we go. Custom command for linking. Interesting. That's interesting that it has ESP32-S2 in the actual cross-compile command. That definitely will probably not work for us in the future. Like, because Sion was talking, Unexpected Maker was talking about like different versions of the ESP line, S line. But for now, we'll just hard code it. It's fine. Like, today is just try to get it doing something. Okay. I'm just going to turn these flags off. Why don't I have wrap on? There we go. And then let's see. This is definitely not right either. We don't want LTO. Yeah, hack it and beautify it later. Yeah, for sure. I'm definitely guilty of that myself. I'm going to ignore the linker file just for a little while. I really don't actually know where I'm going, but I'm basically going to do the things that like I know I've got to change and go from there. Unexpected Maker is making coffee if anybody wants some. I'm not a coffee drinker myself, so I'll pass. I did have a brownie though before I started streaming, because brownies are delicious, and my partner made some. Okay, let's take a look at the. What am I thinking? Tiny USB, lib, tiny USB. Examples, hardware, board support. Let's see how TAC did it. ESP32-S2 Sala. Hey, there's the cross compile. Okay, so we're gonna need these. We're going to need the MCU target, and we're going to need the OS target. Okay, and let's just go through here. The nice thing about starting with the light export is that I really, like, I started that one as well, and I really deleted a lot of stuff, which is always good. So background we want, this we want. This is all standard stuff. We do not need this. And what is the source that we need? Virtual coffee for the chat. Thanks, Scott, for doing that. I don't know where it is. All this CMake stuff is so new to me. That's board support. There's also MCU support. Let's see what's there. There's no ESP. And I know that there's no ESP here because the USB on it is the same as it's almost identical to the ST one. Like they both bought it from the same third party. My brain is just not on today. It's also like starting from scratch. Mark's used CMake a lot. Awesome. Yeah, so the reason I want to stick with Make is that we just have a lot of files and a lot of logic. I don't want to have to copy that all back into this or like reproduce that in the CMake world. One thing we could always do is just compile it. This is what I want to figure out though. I want live USB TinyC source portable. Okay, so let's see. Source portable expressive. That looks like what we want. I know, go get another brownie sugar rush. Well, I think the problem is I ate too many brownies yesterday and I didn't get a good sleep. And then my sinuses were bothering me too. But I took Tylenol for the sinuses, so it should have kicked in. It's fine. Deleting stuff is not that, okay, not that taxing. And I made no promises about how far I get or how long I stream either. Okay, so we found this file, we've updated it. This all looks like standard stuff. This is actually driving me a bit bonkers. There's no reason that we need to have make files for every port because like we're seeing here, most of it's all the same. Which is why I was looking at the Ninja stuff over the weekend. It's just like, one thing that I've been very keen on is factoring stuff out. So one thing you'll notice is that CircuitPython has a single main. I don't know if I pointed that out last stream. We have a single main file here, but MicroPython, as we inherited it and still today, has separate mains for every port. And I didn't want that because I wanted the workflow of like, when are you in this state or that state, or like when your code's running, what happens after your code's done? All that stuff I wanted to be the same. So I've done work to factor stuff out. The other thing that I've done is this supervisor directory at the top is kind of like the other place to start. So let's just do a quick and dirty delete everything sort of thing here too. So this is all Flash stuff. This is all SPI stuff. We don't need any of the static things. But this internal flash.c is something that we do expect to have. So all this static stuff can go away. But this stuff we're going to want. But I'm still going to delete it for now. That can be a separate step as well. Like we can get this, we can get the REPL going before we get the drive stuff going. So let's just pretend it works. And I can just delete the code that's in here because it's always in the other ports still. Like we don't need it. Internal root pointers, and I could, do I have it saved? What's in my, no. I'm sure I'm going to miss some of these, but might as well do them while I'm looking. For the most thrilling stream on Friday afternoon ever. I think the last person to do a port might actually have been Lucian, because he did the STM stuff. So I'm gonna, let's see, port init I want. So this is one of the hooks. Port init is one of the hooks that main.c will call. So main.c will call port init to get everything going. Reset port, reset to bootloader, we don't care about. This is linker stuff that we'll get to. No, not a lot there. Init USB hardware. Okay, so this we can crib from tiny USB, but maybe let's just try. Let's see what compiling does. It's not going to do anything near correct, but it's okay. Make board equals Salam. Hey, it worked. No. All right, our command line options are wrong. So what we can do is we can look at, ooh, drop something. This is, the IDE is Sublime. Although it's not really IDE, I'm just using it as a text editor, so to speak. I don't use the integrated parts of things. But yeah, I'm pretty happy with it. It's pretty snappy. It's not quite as advanced as like Atom or VS Code, especially on the left-hand side, but it's a lot snappier and it's a lot has less pop-ups and distracting things. Does cost money, but that's okay. Okay, let's figure out where these command line options are coming from and figure out if we need any similar stuff for... So we didn't even get to linking, which is fine. I thought we looked through here and I didn't see them, but I wasn't looking super carefully. Let's just take a look at this and how long, Poppet asks, how long have you been coding for? Ooh, that's a good question. I started coding PHP in 2002. I told this, I have a talk that I gave. And good, you're letting me avoid having to find this. I will grab the flag in just a sec. This is the book I learned how to program with. And I actually did date a few of the examples. So if you see here, it says June 18th, 02. So that's when I did this, how to create an associative array. So I've been programming since 2002. And I have a talk, I can find a link, or somebody else can find a link. I did a talk at PyCascades about it. So that would be almost 20 years. I worked at Google for 6 years. I went to I went to the University of Washington and did Java mostly there. And then I've been working for Adafruit for 4 years in August, something like that. And I started the CircuitPython effort for Adafruit. Okay, let's grep the flag. Not letting me procrastinate. Oh no, that is not what I wanted. Ah, what the heck? It thinks it's a flag for... Can I do that? Maybe it's coming from somewhere else. That's kind of weird, isn't it? I must not be grepping it right. Yeah, see, I don't actually know. Let's see. I guess I could just remove the dash. There we go. Oh, it's an MP config board. Okay, that's a weird spot to put it. I guess that makes sense. Okay. Let's actually turn all these off too. Audio. I'm gonna put it in here. No, in the make file. That's usually where we put it. A big long list of C flags. Oh, I only grabbed one of them. But they're the same. This is why I want to factor it out. There's no reason. No reason to have to do this. All right, let's figure out what the compilation flags of that example are. Here. Is that the right directory? No. Okay, so this is the link command. This is a neat hack for Ninja. The way to do a custom command is just have a thing like that. I was like, little weird. I don't know if that's like how you're supposed to actually use Ninja, but whatever. No. I guess we could just look for MABI here. Nothing. See, so build. I think we could have it be verbose when it does this. Let's just do that. Unexpected Maker started with BASIC and Assembler in 1985. On a C64. Nice. I have a C64 right here that I've been meaning to get going. I want to make a CircuitPython cart for it so that you could program your C64 from CircuitPython. Just like my Game Boy stuff that I was doing. All right, let's see what modes this has. Print operation counts and timing. I just want to print. I just want verbose. That's what I want. Well, bam. Eric started on BASIC in 1972. Mark started with BASIC in '87 on the Amstrad CPC 464 when he was 5. Jim did BASIC in 1983. STWNJ BASIC on the Atari 800. See, I think Python's the BASIC of now. Like, I don't think people start with BASIC anymore, but like Python is that thing, and hopefully CircuitPython. Okay, let's take a look at one of these. It's going to be really complicated. But let's just see what's happening. Whew. Okay, so we have the compiler. We have a few defines. I'm just gonna... So this is stuff that we could just steal, basically. Like all these includes, we could, if we wanted to just try to get it going, we could just lift all of these includes that they generated. But the thing is when I looked at the, when I looked at Ninja, it had variables for this stuff. So if we could figure out how to print out the variables, actually, can we print the variables? Ninja print variables. Then we could just snag them from there. So IDF build calls CMake. CMake generates Ninja files, and Ninja actually runs the build. So writing your files, generating Ninja files from code. This is what I was looking at. Ninja file reference. I thought there was a running Ninja. Oh, here it is. Prints the help output. Tries to act like make. Query. Browse is pretty cool. That's what I was doing here. I was browsing the dependency tree. Targets, commands, clean. Compiler DB, which is cool, so you can use clang tidy. Variables. I mean, it tells you how to use variables, but it doesn't tell you. I'm not sure where they define them. All right, so these are all I's. Let's just leave them there. And then there's this stuff. Things we added. MD makes dependencies, and T does as well. Something like that. Yeah. Okay. It doesn't look like there is any. Doesn't look like there's any architecture. So let's just lift these C flags and we'll delete these. And let's just yank those. I'm wondering if we can... I'll have to decide how to do this. Because we could make targets for the statically linked libraries and then pull those in when we link everything. All right, we don't want this one either. That's a RISC-V thing. And no start files. I don't think we don't need. Let's delete those two. Sure. Let's see what it does. Haha. Forever and ever. Okay, so one thing that's interesting here is this is showing us all of the files it's trying to include. For example, I thought I saw it. Yeah, like pixel buff, touch IO, OS, storage, struct. Like we don't want any of that stuff. Like we want to chop this down as much as we can to just like main and like making math work. There is a minimal build flag that Lucian added with the STM stuff that maybe we should try to turn on. Yeah, so in npconfig port, what happens if we do CircuitPy minimal build? Really just trying to limit the amount of files that we have to pull in. Make clean. I haven't found a good meta build system that that is designed around having lots of configurations, right? Like in CircuitPython, we build one artifact for every board times every translation. So like having a thing that handles boards well would be really nice. All right, let's figure out why this is unhappy by, again, just looking at seeing where it's defined. It's not defined here at all. What the heck? Where did it go? I have a, like it should be defined by default. But no, it's in all of the npconfig ports. Like that's so silly. npconfig port.h. Like, there's no reason we have to say it whether we want micro.json or not. Oh, nice, Poppet. You started 7 years ago with Scratch. Ah, that's true. Lots of folks are learning via Scratch now too. Make code is great. Mark says it's probably all default as it's a specific port of GCC for the ESP32-S2. Yeah, that would totally make sense for like the architecture flags and stuff. Dennis learned C in 1992 and two guys told me about this Linux thing. All right, let's see how far we get. Rinse and repeat. Oh, come on. I need to do it before this. Because order matters. All this stuff we should figure out how to redo. 307. Let's shoot for 2 hours again. Okay. Ah, interesting. So we're redefining config TUSB OS again. Here we go. This is where we start to get more interesting. What I think what we should do is hide this between an if not defined. So we only define it as none if the port itself is not overriding it. So let's go into supervisor, shared USB, TUSB config. And this is, this is where we want to do it, but we might have a makefile ordering problem. We will see. We might want to clean too. I lost my train of thought. I was going to say something. All right, here we go. Now we're starting to find the things that we need to start adding as includes. But maybe what we should try and do is do what Ivan said. Sorry. This chair is designed so you don't sit in the same spot for 2 hours. So I'm like swapping different positions. Let's see if we can't find where the list of includes is saved for Ninja in that example. So I'm going to add a new directory. Let's close this. Project, add folder. And I'm just going to add repos, tiny USB. I know you can't see this. Yeah, repos, tiny USB. That's what we want. And then we were in examples, device, CDC, MSC, free RTOS. And we can look in build and like build Ninja. Like here, it has rules Ninja. And if we open rules Ninja, we have includes here. So I wonder if it must be in the environment. I didn't think Ninja. Ooh, this looks interesting. No. All right, let's get our magic, our silver searcher out. This is gonna generate too much. Oh, look at that. Includes equals. So what file is that in? I wonder how much they vary. Look at that. It's like, such a huge file. It must be, you think it's redefining? It might be in Ninja build.ninja. And it just resets it as it goes down through it. Which is kind of unfortunate. Like ideally we would just have one set of includes that we compile everything with. And theoretically we could just do like a set of all of them. But that wouldn't work if there was includes of the same name in different directories. All right, we're getting to the top. Okay, so it is in Build Ninja. So I had it open. And I just missed it. It was like right here. Ah, okay. So includes is a variable that's passed into the build rule. Interesting. I'm trying to think, like, if this was already set up, we could just call Ninja, and that would be easy. But that takes running CMake. So let's see what the hell it, let's see what the docs say. Partition tables, application startup flow. We don't need that. Let's see what these docs say. 40 nanometer technology. Start a project. Copy. Does not support spaces in the paths. So maybe there's just like a CMake. What's the README say? Very simple examples with minimal functionality. That sounds like what we want. Although build system could be interesting as well. Make multi-target support readable. let's do hello world. Okay, cool. Start to free to RTOS task to print hello world. What does the make file look like? It's assumed that this make file is in a project subdirectory. Mark votes for blank. Okay. We could take a look at blank too. All right, so end of IDF path, we can. Let's take a look at blank. I don't have my overhead working, so I'd be the only one. Well, I could hold it up. But okay, let's do that. Let's crib this. And we'll close this, open this. It's probably what TAC used in TinyUSB as well. Project CircuitPython path. Hopefully it's relative. ESP32-IDF. That. And then in make file. What did they have in the make file? Sure, let's give that a try. Let's just import all of their stuff in and just see how well it works with everything. And again, I don't want to do IDF path because I know where it is. All right. And I was looking at the browser. Can you hear the neighbor's RC car? They're having a good time. Oh wow, look at those defaults. SDK config.defaults. I assume I need that. So who's doing the housekeeping? What sort of housekeeping are we talking? Oh yeah, it's an RC car, not a vacuum cleaner. I have the windows open. They're out in the driveway, outside the window. Okay, this still isn't gonna work. A sewing machine, interesting. mconf-idf is not required on this platform. The following Python requirements are not satisfied. Hey, Johnny. You didn't say hi to me, but I'll say hi to you. Okay, so what we can do is, like, I'm totally okay having Python dependencies. So I have this generic virtual environment that I'm actually just going to pip install all of this stuff and see if I can make it happy. Less than 2.4.0. And this will be, it always confuses it. GDB GUI. I'm definitely of the, like, I don't want all this stuff. I just want the stuff I need. So I could, like, have a virtual environment where I actually, I mean, it's checking, but I would be okay with, oops, I uninstalled PyParsing. Didn't want to disturb my thought process. Yeah, my thought process is not top of its game today. So it's totally fine. If it makes for a like mildly more interesting stream. But these are deep dives. They're not meant to be interesting. Like you can have a coffee, read the newspaper, and listen to what's going on. All right, let's see what happens. Pi GDB MI must be 2 new. Look at that version number, 4 digits. Yeah, I meant equals. Thank you for the nice error message. I had a 2 new object. Hey, something happened. Menu config, I've missed you, so... That is not what I expected to run, but okay. SDK tool. Build type. Yeah, I just want second stage bootloader. I really don't like menu config. This is certainly not what I want to happen normally, but we could just go through it. All right, let's call it good. Relative to build. A nice uplift on menu config as well? You mean, what do you mean by that? Of course they're interesting. It's nice to see someone else struggle on a stream. Yeah, it's true. It's programming on streams should not just be like, oh, I'm a wizard coder. Let me do some awesome things. Like, I do awesome things. Follow my GitHub. Just not usually on a stream. Oh yeah, facelift on menu config. Sure, I buy that. All right. Let's see what it does. Well, it didn't pay attention to my build directory. Or figuring out how to do that would be cool. Yanni says, programming wizardry. Yeah, not quite a wizard. It's a lot of grit. A lot of grit getting through errors. It's fine. That's why I wanted to show this start, like, because the start can be pretty rough, right? Like, getting all the includes right and things like that is like, this is, I think, probably the hardest part of doing a new port. And this port in particular is challenging for what we talked about before, like free RTOS and things like that, but also that it's a completely different architecture as well. Okay, well, we're back to square one. The other thing that we can look at is we can look at see how MicroPython does their ESP port. So this is MicroPython ports ESP32 makefile. Now they're still using ESP IDF 3, not 4, but maybe we can still integrate. Like there's the cross compile, SDK, pass to the IDF, find the K configs, verify the version. Oh, look at that. They even have like a nice. This looks good. You say there's no 4X support, but it looks like there's at least some. Okay, yeah, they support 4X, but not CMake. Yeah. That could be true. Support BLE by default, which we can't do. Compiler flags. Ooh, here's all the includes. Maybe we should steal these. We could do that. Although, like, yeah, Ivan's suggestion was to find a place to output them. Find a place to output them. And then use them. That makes sense, right? Because we ideally were less tightly coupled. Those are not S2 includes, that's true. Yeah, and that's, yeah, my brain is just not super here today. I don't think that we want to bring everything in. I don't think we actually want to do this. I think that between their stuff and our stuff, I don't want to... No, I don't want to do that. What do I want to do? That's the question. So what I was talking about is that we would end up compiling our stuff with different flags and then linking against the ESP32 stuff that does have all the flags. So I wonder if we can simply... So we need all the includes. Johnny says, I have no idea what you're doing though. So we found... Mark's looking for me. Thanks, Mark. All right, let's look at Mark's suggestion here. Since my brain is checked out on weekend. Components, ESP32-S2. CMake lists, line 38. Is that what you mean? That doesn't look like what you're thinking. Set sources, that's for the bootloader. The second stage bootloader, which sets up all the partition stuff. I need to give more context. Yeah, see, Mark, you understand CMake. Which is my issue. Like, my issue with CMake is like, I saw this, I was looking into CMake and it had this thing of like, treat it like code. And I'm like, if I'm going to have a meta build generator that's like code, why wouldn't I just do it in Python that I already understand? But then again, I'm definitely biased towards Python. CMake lists up a folder. I'm not in test. I can open test. I'm in ESP32. It might be a little small on the stream. I understand that. So I am in tests? How do you know I'm in tests? This file doesn't have, can't see it, the full path. Doesn't have tests. There is one in tests, but that's not the one I'm looking at. Small screen. Yeah, no problem. I get it. I could make my font bigger too. So I'll take the blame. And delayed chat. Yeah, it's fine. Okay, I feel like this is getting less interesting by the minute. Let's just cheat for now. And I will just hard code it. So let's look in. I'm gonna have to like, this is not a trivial topic. Figuring out how to do that. I will push anything that I change here, so if folks want to help, I'd love it. Here we go. Examples device free RTOS includes. Here we go. Let's just do that. There's a couple free RTOS includes here. There's that one. And there's this one. And let's just see if that gets us farther. Which it should. Am I still importing? Thought I removed it. I really don't want to do that. And it didn't work. Let's clean it. The thing, it's always good to clean with the make stuff because it's auto-generating a bunch of stuff in the background. We'll do clean and we'll also do print everything. Q strings. And trying to compile stuff. Our includes, oh, my posture is terrible. Our include is listed there. Maybe I needed, oh no! I just knocked water on my keyboard. Luckily, it's not very much. I will use socks to soak it up. Should my response to knocking water be grab another full glass and set it in the same spot? It's not like my desk is covered in electronics anyway. Oh, maybe I should just give up on streaming. At least drinking water. Drinking water and streaming. The keys are all wet now too. I didn't think I had that much water in here. It's not a make full clean. I just saw make full clean for the first time and I was like, wait, what? Why would you have two levels of clean? Dihydrogen monoxide? Fish doesn't understand. At least it's not a cat on the keyboard. Not an actual Mac keyboard. I have a dripping water still. That's not good. I've got keyboardio. I only got 1/2 of it, so, you know, if I lose my right hand. Jeez, there's a lot of water in there. Oh, this is the full clean? It's true. I mean, I should probably let it dry. But enter keys on that side. I could open it up too. Let me just shake it out. Fish needs water. It's true. I didn't realize I had that much water left in the glass. Let me finish this one. I could grab another keyboard too. Let me do that. Let me let this one dry out. Just pour alcohol on it. All right. My typing will get even worse. I haven't used this keyboard in a while. But I can hit up and I can hit enter, so let's go with it. My floor is all wet too. I really didn't think there was that much left. Like, I have a full glass behind me. I hadn't even switched to it yet. Let's see. My brain it's a new keyboard. We'll call it soon. If folks have questions and get me back on track, that would be awesome. I'm looking for free RTOS.h. You know what? It may not be there at all because it might be in a sub. Oh, it is. This is the path. Oh no, I don't have a second free RTOS in the path. Interesting that this build system CMake IDF as a lib stubs has it again. And it's also interesting, maybe TAC shouldn't be doing bare free RTOS, but that's okay. So here, let's, in our cheater, new keyboard. That save. There we go. Hi, Alvaro from Costa Rica. Thanks for joining in. This has been hopefully interesting stream where I struggle with build systems and then spill water on a keyboard. Hey, progress. Lots of progress. All right. Now FreeRTOS is looking for an ESP compiler.h, which let's just do the same trick and find it. Oh, man. This is not the keyboard I normally use. It is at least in Colmac. It's just so close together. It's weird. ESP common. Mark says this is the most exciting stream I've seen in ages. I don't know. I think your streams are more exciting. Mark says the components I need are ESP32 FreeRTOS and ESP-Tool.py. You can type. The problem is the autocorrect. All right, let's just add that too. Let's make at least a little progress, shall we? Ooh, I do like how clicky this keyboard is. It feels clickier than my other one. Oh, that looks right. Minimal is all I want. I'll have to start spilling my coffee on my desk during a stream just for the drama. Yeah, I wonder, was it very dramatic? I don't know. Jonah asks, can you explain the advantages of a build system and why it is important? What one does CircuitPython use currently? That's a great question. A build system is, so we currently use Make, and Make is a kind of the de facto one that people have used since the 80s. And it's great because it's got a ton of documentation, and it's like reasonably well understood because it's been around forever and a lot of projects use it. The more modern stuff, from what I can tell, is ending up being split into two. The single thing that Make does is split into two. The top high level stuff is like a meta build system, which takes a look at all the configuration of the project, and yeah, I'll show you the includes. Mark's doing all the work for me. It's great. So the meta build system, like, it figures out like what all the files are and what files depend on other files, and then the lower level of job of a build system is to track how your files change, so that when you change one file, you don't have to recompile everything. So it has like a dependency tree that it knows, and it knows that like, oh, you changed main.c, and main.c needs to be compiled, but then you can link it with all these other files that were already compiled. In modern systems like CMake and Meson or Meson, they use a system called Ninja, which looks a lot like Make, except it doesn't have as many fancy things. Instead, it's expected that you generate the Ninja files from another system. And then it manages the like, oh, this file's new, let me remake this and everything else that depends on it. Which is quite nice. Which is why I don't understand CMake enough to just move us to there. Cool. Mark's doing all my work. Thanks, Mark. Components. ESP32-S2. All right, let's see what we get. All right, and I'm actually going to grab my other water so I can spill it on my desk too. Okay, so there's two things that we're missing: sdkconfig.h and this configuration thing. So let's see if we can't find. Jonah, did that answer your question? And are you TG Techie? I think I know who you are. Ha! I was right. Okay, interesting. So I wonder if SDK config, let's do the same thing in the tiny USB example and see if there's, oh, actually there's build include. Let's use that. And the problem is that I don't think we're, like, we actually have 2 build files going. This build include file is the build folder that it's including Flash stuff you don't need yet. Why do you think that? It's certainly the SDK config. I think it's probably a file that gets generated. Let's just include that. Let's really do nasty things that are not going to be good long term. And do build include. Oh, this keyboard is so different. Okay. We'll just use that one. I want to redo this QString stuff too. Oh, that didn't work. I thought that's where we found it though. In build include. Oh, stupid keyboard. This QString stuff is so annoying. Heyo, it's a little further. We didn't get the optimization perf thing out of the way. I think this is exactly what Unexpected Maker did not want us to do and hardcode all this stuff. Components, extensa, include. But we can always redo it later. It's actually like most of our ports just hardcode it. So it's not unheard of to do it that way. Extensa config core.h. Components ESP32-S2 include. We should be including that already, but it's in brackets instead of quotes, and that changes things, and that might be the problem. Does that make it absolute rather than relative? I think it does. Sometimes it's advantageous to just say you can redo it later and then never redo it later. Extensa include on line 75. Oh, okay. I see what you're saying. This is the other reason I wanted to do this during a stream, is like you all are so helpful. I didn't find it. I thought that's where it was. Components, ESP, components, extensa, ESP32 include. Like that, I think. Even if we don't like have this sort of system long term, it's like me and us starting to learn how it's all set up. Oh, now I have 2 includes, don't I? Yeah. So since our theme is like the nitty gritty of programming, you might think of this, I might think of this as wasted work, but in reality it's not, because you're learning stuff and you need to understand it so that you understand what parts you want to keep and what parts you don't want to keep. Now this is interesting because why would it be including ESP32 ROM ETS sys? Well, we definitely don't want that. We want... Let's open this file. All right, we got 10 minutes left, so I don't think I'll keep going. My brain is just not, it's not here today. I was hoping that being on the stream and like focused, I would get focused, but my sinuses are still fogging me up a little bit. Okay, ESP components. No ROM in the ESP32-S2 folder. Oh, do you think it's just... I guess we could look, right? Because we found the includes in the Ninja file, which I no longer have open. Unless that's what this is, which it's the copy of. So let's see if we can find ROM. Okay, components ROM include. Colmac and a new keyboard. Tom, I guess I don't have to read this off. You can see it, but I guess if you're not watching, this is some scary stuff. Command line IDF. Wow. I go back to my Arduino IDE. Thank you very much. Well, the idea is that like once we get this going, like this is a deep dive, right? This is the bottom of CircuitPython. CircuitPython, once we have it, we'll produce a file for CircuitPython that you just install on your ESP32-S2, and then you'll plug it in. You'll see a drive with a Python file on it, and you'll edit it. You don't have to deal in this stuff at all. This is just the deep dive in the weeds, the stuff that Adafruit pays me and a few others to deal with. All right, we're making progress. So we are collecting like config stuff that we're not. Okay, cool. Jonah says the reading aloud is good. Yeah, in case you're not watching. Totally get that. It's like if I'm on a podcast. Okay, so we're ESP timer stuff. Okay, we can find that. We can do the same thing. Maybe by the time... Mark asks, can Adafruit pay me to do this stuff? I need a job. Yeah, Mark, email me. Maybe, actually. I'll have to ask, but we do contract stuff. And if you can CMakeify everything, then yeah, maybe. So yeah, I'm just Scott at adafruit.com if anybody wants to email me. M on Periscope asks, what are you doing? I'm currently trying to get CircuitPython on the ESP32-S2 building, but we're making progress, but I don't think it's going to happen today. Yeah, Jonah's coding at the same time as listening. Okay. I kind of like how this is laid out, but I couldn't foresee like, oh, if I'm going to be another component, does that make sense? And then, Mr. Certainly Seconds saying, I'll second the reading aloud part. The best streamers are those who can enjoy while watching in audio only mode. Mark says, I'll email you. I could see Makeify it for sure. Yeah, please do email me. Because obviously I'm new at this stuff. So I'm good at other stuff though. And if we just get a little injection into the ESP32 stuff, I wouldn't be surprised. We're pretty excited about this chipset, and I think that Unexpected Maker is very excited for us to support it as well. And like I said earlier, like this really is the hardest part of a port, because once you get the build system up, you make it clear like, oh, you added this thing, you have this dependency, you add it to this line, and that's simple. So yeah, this is, I don't feel bad for struggling with this. This is something that happens, this is the 8th time, like the 8th time in almost 4 years that we've done it. Like it's just not something that happens all that often. It's super critical, but it takes time. Component sock. And if I was paying attention, I would be sorting these as well. But it's fine. Sorting is easy to do later. CPU LL. And this is kind of nice, like, yeah. I like to know what I'm including. I don't like to just include everything. Although it looks like the organization's, like, with all these components is pretty nice. Toddbot says, no, don't sort. The order shows the gremlins you vanquished. Yeah, but I'm not even putting them in order either. So it's not like it's the gremlins in order. Sorting is way nicer when you go back to look at your code and you're like, oh, is this in the list? Like, things should be sorted. It's nice for your future self. I was like, wait, did I just make the same thing? But it's like off by 1 letter. Sock instead of sock source. What do you think CAPS stands for? I don't even know. This is a pet peeve of mine as well, is that programmers think that short is clearer, and it's not. Especially when you use a short thing like CAPS. Like, it could be capabilities, but like, I'm a native English speaker. What if somebody's not a native English speaker? How do they know what CAPS means? Like, should always like try to write everything out. We have tab complete now. It doesn't matter. Mark says Zephyr does a really nice thing where they make a wrapper for each vendor's HAL, and they include that links into their build system. They also use device trees to specify which on each board. Easy. Yeah, Mark, we need to talk. I looked at Zephyr, and their makefile, their CMake file actually was one of the reasons I'm like, I really don't want to do this. Because I was looking, I have a couple Zephyr stories. So I looked at this, which is their top level one to be fair, but like, it's super long. Like 1,500 lines long. 1,400 lines long. And I'm just like, if I'm going to have logic 1,400 lines long, why wouldn't I just write Python? But the appeal, and I think the pitch is like, if you use CMake and other people use CMake, you can integrate with it. And then the device trees are really interesting too, because yeah, they describe what's in each microcontroller and board. I had some discussion with Esden about using device trees for the FPGA work. So we would be able to do a single build, and then the device we would load the device tree to tell us like how many SPI peripherals and stuff are there, and what are their offsets and things, which could be cool. But the other thing that I was looking in Zephyr is like per board, there's like 5 different configuration files, and they're all different formats. I was like, what? I would love to see just like a unified, like, here's just like machine readable, human readable versions that just tell us. Yeah, device tree is Linuxy. Yeah, so Zephyr is maintained or sponsored by the Linux Foundation, so they inherit a lot of the Linux world. The other story about that is I'm actually on the technical steering committee for Zephyr. Well, Adafruit is, and then I'm the one that goes to the meetings. Jonah also says, it's great to see your process, and it's awesome that an example of one way to step up a build system is now available online for CircuitPython forever. Yeah, how to bring it up. Except I haven't actually brought it up yet. It's kind of just this process. Over and over and over again. Till it works. Till you run out. I mean, I kind of what I would expect is like I'm gonna run out of includes that are missing, and then I'm only gonna be missing like these defines. And the other kind of Linuxy thing that's in all of this is kconfig. We saw the menu config briefly earlier, and that's I think the other missing piece for just hard coding is we just have to pound define a bunch of like -d define a bunch of stuff if we wanted to continue in this vein of just hacking it together. So yeah, this is what I was thinking. Like, there's no include errors anymore. There's just a bunch of stuff that's not defined. Actually, you can't see that, can you? I'm sorry. I brought it off the screen. This is what I was just scrolling through. So all the things that it's now complaining about are things being undefined. Nice. Mark says there's a lot of stuff that Zephyr is moving from the other config and /build files to the device tree. I'm doing some stuff on the STM32 ports. Awesome. Yeah, one of the challenges that we've had with Zephyr, and we've started to talk with those folks, is that we're actually very dynamic in the way that we allocate pins and stuff, pins and peripherals. So some of the things which I think you do in device tree with like the choice block, like those are things we wouldn't actually want to do. We'd want to do them dynamically. And that's kind of the challenge, is that we're an oddball when it comes into the embedded world, where like we don't actually know what the user is going to do. Whereas most of the HALs that are created in Zephyr, like the RTOSs, they're all geared towards like, and this is true for the ESP IDF as well. It feels like they're geared towards like, oh, I'm making a smart outlet or a smart light bulb, and I'm going to put it on a board, and this pin is always going to do this, and this pin is always going to do that, and we'll always fix like this circom will be the UART and blah blah blah. And like there's a lot of knowledge that's baked in at compile time that in CircuitPython we just don't bake in. We want to include all the drivers for all the peripherals, and then we want to be able to like allocate them at runtime instead. Okay. Mark says, oh, I've got basic support for the Pygamer in Zephyr. Blinky works. Nice. All right, so this is, I think, where I'll leave off. We've been going just around 2 hours, which is a while, and especially since it's been kind of like hopefully interesting, but definitely in the weeds. I think I'm going to continue working on this. If anybody wants to follow along, I encourage you to join the Adafruit Discord server, which you can do by going to the URL adafru.it/discord. Hop in there. You'll see us chatting in Discord all week long. We do get notifications from the GitHub CircuitPython into there as well. And then the other way, I've chatted with a few people about like how do I lurk on what's happening in CircuitPython, but kind of at a minimum. And the other thing I would recommend is that we have a community meeting on Mondays at 11 a.m. Pacific, 2 p.m. Eastern on that Discord server. The videos go up on the Adafruit YouTube channel. So if you can handle 2 hours of me talking, you can handle those meetings. But if you don't have that time, we also do take pretty good notes. And the URL is this Adafruit/Adafruit CircuitPython weekly meeting. We actually have our notes all the way back to the very first one, September 18th of 2017. So you can check out the notes here. So what you can do is if you just skim these, you'll be able to see kind of get a feel for what's going on and where we're at. And it shouldn't take you too long. The notes also have time codes. So if you do want to like hear about this bit, you can seek into the video around the time code. They're not super precise to hear the like discussion or anything. So yeah, that's how you can keep track of it. I think I am going to try to keep streaming on these Friday afternoons for about this 2 hour window. So hopefully next week, I'll have made some progress. Like my goal is to not kind of like this week was like literally picking up from where I left off last week. My goal is not to do that. My goal is to hopefully like get my brain in a state where I can focus and hopefully collaborate with Mark on getting this going and getting that. Like, what's a good analogy for this? Like one analogy is like laying the foundation for a bunch of work, but that doesn't feel like it's like it doesn't characterize the amount of work that kind of it takes. Like with a new port, especially one like this where you're bringing in a huge library that you want to build on top of, it's kind of like a learning curve where it's really steep and then it'll level off, right? So once we get this workflow stuff going, then we'll be able to handle it. We'll be able to do stuff in parallel. Like I can work on digital I/O, which is probably the first thing that'll get working, and then like bus I/O and pulse I/O and NeoPixel. NeoPixel is going to be really interesting, as Unexpected Maker has been chatting with me about. Like NeoPixel, what we typically do is we basically stop the world and bit bang it out because it's relatively timing sensitive. But in a world where we have a real-time operating system, we can't rely on that. So we actually have to use a peripheral to do it instead. So that'll be interesting. And of course, we're going to do that because Adafruit's known for NeoPixel. So that'll be interesting as well. And then, of course, for me personally, I'll probably like really jump onto networking. A core piece of an ESP32-S2 is the Wi-Fi. And we haven't looked at that in a long time. And so I really want to take a look on the API side of how to like have good API boundaries and stuff where most of our like we can swap out like are you using native Wi-Fi, are you using a LTE module, that sort of stuff. So we got a couple of suggestions for an analogy. Jonah says scaffolding or laying bedrock. And then Mr. Certainly says it's like framing a house. Once you get that up, you get the plumbers, the electricians, the HVAC, the insulation, etc., and to do their job. Yeah, I like that. The framing a house, like, and like they build a lot of houses around here right now, and like I kind of see the effort of like hoisting the walls up and stuff. So yeah, that's a good analogy. Getting the skeleton laid out. Okay. Let's see. The other things I should talk about wrapping up is I work for Adafruit. I get paid by Adafruit. So if you want to help them out and you want to see more rambling streams from me and leverage CircuitPython, please support Adafruit because they support me. You can actually support me directly on GitHub as well. I do have GitHub sponsors and have 2 right now, which is cool. One of my tiers is cat photos per month, which is kind of neat. And the way that you can support Adafruit right now is they're not shipping from Adafruit HQ because they're in New York and they're shut down. They're doing PPE stuff, but they're not doing any sort of manufacturing or shipping for kind of normal hobbyist folks. Is buying by buy from DigiKey instead, so you can buy Adafruit stuff. They're a reseller, and turns out you can actually go. The Adafruit site now has links directly to the DigiKey corresponding page, which is actually very neat. So let's just see if they have it here. Yeah, so here's the Feather NRF52840 and we can just click buy on DigiKey, and that will warp us to the DigiKey page for it, and we can see that they don't actually have it, unfortunately, but other stuff is in stock. And I know for a fact that they actually took stock from Adafruit, and they are putting it in DigiKey's warehouse, so they can do that too. Mr. Certainly also points out that you can buy gift certificates, which are great because they never expire. So once Adafruit gets going again, you'll be able to buy all these ESP32-S2 boards that will be coming. And then also Adafruit IO subscriptions are helpful as well. They're still available. Okay, yeah, I think that's my spiel. I'll thank you all so much for watching and hanging in with me as my brain farts and I spill water all over my keyboard. I appreciate it. I do enjoy doing these streams, even though I don't necessarily always get a lot done. So thank you so much. I'll see you next week, or I'll see you on Discord before then. And have a great weekend and take care of yourself.